Alright, this video is for January 13th or 17th, unless you are in 3B or 4B. If you're in 3B or 4B, this will be January 19th. Solve one equation. I'm going to go ahead and solve the next one and point you in the right direction for the final one. Here, let's say we want to solve this equation. Again, we have the half angle formulas here. What we did in class is say, hey, actually, most beneficial might be to keep it here. Some people said we have a half angle, so let's replace this with our formula up here. So instead of sine squared of x over 2, we can replace sine of x over 2 with your formula. So let's go ahead and do that. Cosine squared of x equals positive and negative square root 1 minus cosine x, over 2. We're just using the formula here, replacing it with this formula because of the half angle. Replacing it here, squaring that. Now if we do that, similar thing, the positive and negative, if we square it, that would go away, and the square root would go away, because the square root squared, that goes away. So we would have 1 minus cosine x over 2. Now there's a lot of things we could do here to solve. I'm actually going to do it two different ways just to get kind of everything on one side. One thing we could do is subtract cosine squared and get 0 equals 1 minus cosine x over 2 minus cosine squared x. Now we want to get rid of this 2, so what we can do is multiply by 2. So I'm going to multiply here by 2. However, one thing we need to be careful with is if we multiply this by 2, you're really multiplying the entire side by 2. So we also need to multiply this cosine by 2 as well to make sure it's distributed properly, right? We're multiplying both sides. 2 times 0, that'd be 0. These 2's, you would be left with 1 minus cosine x because these 2's divide out. And then we're multiplying this by 2, so minus 2 cosine squared x. Similar thing here, if instead we go from the start and say, well, if I multiply this side by a 2 and this by 2, then I can get 2 cosine squared x. These 2's go away, 1 minus cosine x, and then subtract the 2 cosine squared x. Either way, you get the same thing. Okay. Now I'm going to bring this back up here, and when I do this, I'm actually going to rearrange it. I'm going to go from the highest degree to the lowest. So I'm going to rearrange it as negative 2 cosine squared x minus cosine x plus 1. Oh, excuse me. Just rearranging so I have the square term, then just ABC, if you will. Now we have a quadratic, and the idea is here in the quadratic you can solve this. You could use trial and error or the AC method. I'm going to do the AC method because I think that's what majority of people prefer. I'm going to multiply this by negative 2 minus cosine x minus 2. Now I'm looking for two numbers that multiply to give me negative 2 that add to negative 1, and those numbers would be negative 2 and positive 1. Negative 2 times positive 1 will give us negative 2. Negative 2 plus 1 will give us the negative 1. Now, again, I've said it many times. The reason I don't like the AC method is whenever we multiply by here, we need to divide here. So we would get cosine negative 2 divided by negative 2 would give us a positive 1. Positive 1 divided by negative 2 doesn't come out even. It gives you a fraction or a decimal. So this negative 2 goes in front of the cosine. Now we have two things that are being multiplied together. It equals 0. So we can say, hey, this equals 0. This equals 0. And now we have two equations we can solve. Subtract 1, subtract 1. If you subtracted 1 divided by 2, what you would end up with here is cosine of x equals 1/2. Subtract 1 divided by -2. And now we look, where on our unit circle does x equal -1 or cosine of x equal -1? Well, here x would equal pi. And here x would equal pi over 3 and 5 pi over 3. Because that's where cosine equals 1/2. Alright. There's two main pieces here in this equation. The first piece is here. Understanding how to get 0 on one side, ending up with this form. So multiply by 2 from the start here, or if you put everything on one side, making sure you multiply every term by 2 due to the distributive property. And then finally is, if we recognize we have cosine squared, a quantity squared, just that quantity, and then a number, what we can do is rearrange it as a quadratic. And so we can rearrange this as a quadratic and solve by factoring, which we did here. If you have questions on this one, please ask. We'll also review this for the assessment review. So be looking for that when we review for these problems. Review for your assessment. Now, I'm actually going to flip to the back side. This problem is interesting. You can solve this. However, you're going to need a Pythagorean identity. So eventually you're going to need to use this identity to replace sine squared. So either you can say sine squared of x equals 1 minus cosine squared x. This will help. Or equivalently, if I multiply this by -1, negative sine squared x, multiply all this by -1, you get kind of like cosine squared, just changing the signs, positive cosine -1. Either one of these, if you use the half angle formula to solve this equation, similar to what we did in the previous two, you're going to ultimately need to use the Pythagorean identity to solve this equation. We didn't solve this in class. I kind of left it as a more challenging problem, but you can solve it using this. We did solve this equation. And what we noticed is here, you could use a half angle here and say this is plus or minus square root 1. I'm kind of going a little quick. A for time, and B because we kind of already replaced the half angle here. 2 theta equals 1. So I would encourage you, think about it conceptually. How can you simplify this? We've already done that twice, so I'm not going to go through that. But if you do simplify this all the way down, it's still going to be hard to solve with this sine of 2 theta. So what we can also do is use a double angle formula and say this would become 2 sine theta cosine theta, using the double angle formula that we covered last class. And if we do that now, we can hopefully things would happen to where you would be able to factor and get solutions on their own. And if you do that, what you should end up with is, let me make sure I'm doing my math right really quick. If you factor, you should end up with this. And this part of the solution would yield solutions of pi over 2 and 3 pi over 2. This piece of your solution set would give you 7 pi over 6 and 11 pi over 6. Try it out, see if you can solve this one. If you want to challenge yourself, go to this one, solve it, see what you can get. If you have questions, please feel free to email me, ask me at any time. I'd be happy to answer.